Thanks for coming. It's getting to the end of the conference, late in the day. Please don't fall asleep on us. We're going to talk today about, well, the title is The Demo Gods Are Not on Our Side. I mean, when are they ever on our side? So today you could certainly see grown men cry on the stage, and what we intend to do is represent some, what we consider to be real-world scenarios in terms of failure, things that it's not a question of might happening, but they do happen in production, and particularly when it comes to distributed systems. So my name's Christopher Hunt. I'm on the production suite team at Lightbend, and this is Ed Callahan and Marcus Jura. They're also on the production suite team. And so we've developed a number of technologies of the production suite. We actually run these in production ourselves. We are in Lightbend engineering, but we are DevOps. We run these things for real, and we have customers using these systems, lightbend.com itself, and reactivesummit.com, and all the associated services are actually run on this infrastructure. So this stuff is real. And that's what we're going to show you today. So we've done our little introduction slide there. So I wanted just to give you a very quick overview of what this production suite thing is. And in particular, start with the why. Why is Lightbend getting into this traditionally sort of ops space? And what we see is that developers are increasingly responsible, of course, for looking after what they develop and put that into production. This is a very, very positive thing, right? Because we, as developers, when we know that we have that prospect of getting the 2 a.m. wake-up call because we've written some pretty poor code, then we tend not to write poor code as much, all right? And so it's a scary prospect, though, for many developers. I was actually on site at a customer not so long ago where I was giving a similar presentation, and they said, so what is the presentation about? I said, well, we're covering some production-style scenarios. And we said, production's a dirty word around here, And that is often the case in organizations, particularly large enterprise. I don't know, you may have colleagues who also feel the same way. But this is the world that we are now living in increasingly, and our employers are expecting us to do this. And so Lightbend as a company, we've always been there for a developer. It is in our heritage to do that through Scala, Akka, Play, and now Lagom, and the OSS communities that we build through that. And so we want to take this further and hold developers' hands through into this brave new world of DevOps. And so that's the why. And so to give you an overview of what the production suite comprises of at this point in time, we have components that look after the service orchestration aspects of managing your containers in a production style, in a highly distributed and resilient manner. We have monitoring, where we can make observations and yield metrics and traces and logs and events that can be captured in a what we consider to be a very reactive way. And given our involvement with Scala, Akka, Play, and Lagom, we can instrument these toolkits in these frameworks at a very low level to yield some very fine-grained data then that decisions such as auto-scaling ultimately can be made upon, rather than relying on coarse-grained metrics. And then finally, in the list so far, we have something called split brain resolution, and it was mentioned in this morning's keynote what split brain was all about, which is great, so I don't have to cover that topic again, because I'm sure you all went to that this morning. But it's largely an unsolved problem in distributed computing, and unfortunately, it's not one of those things that just appears every now and again. It actually does happen, right? And it's often not a problem for many people today, because not many people really today are dealing with distributed systems. But with the advent of microservices, distributed systems are being forced upon people. And so if we go through some of the individual components a little bit more, indeed, the entire goal of the production suite is to provide this batteries included approach to things. These stacks tend to be very, very complex. I don't know if any of you have tried home growing your own orchestration solutions on EC2 or Azure or OpenStack or whatever. But you will find yourself typically spending 12 months to your best people, and then you have an ongoing liability to support and maintain it. These things like build tools seem very, very simple at the outset until you actually then get into it. And so we want to make sure that this can be as simple as possible, and particularly from our perspective with our Reactive platform, we want to make sure that it's looked after to the best we can see that it's looked after in this regard. We have no single point of failure, so we carry our heritage, if you like, of Reactive through our influences through Akka. In fact, actually, the production suite can be looked upon as a manifestation of Akka. In a runtime sense, in many ways, we build on Akka clustering. It's highly distributed. It is AP over CP, by default. Not to say that you can't have a bit of both going on in your world, but it has that heritage. We automatically fail. We do automatically fail, but we automatically recover from failure. We'll be showing some automatic failures later on. But we automatically recover from failures and promote self-healing. Again, we really think that it's important, as developers ourselves, running our own stuff in production, we do not want those 2 a.m. wake-up calls. Actually, another way we've kind of solved that issue is that our team here is actually distributed across the planet. I'm in Australia, you're in Hamburg, and you're in San Francisco. So that's another way of dealing with it too. But supposing you all live in the same place like normal people, then you don't want that 2 a.m. wake-up call. So we're very big into that. And small things, or seem small, like logging, being able to consolidate your logs over many, many machines. In our 1.0, when we were working out what the MVP was a couple of years ago for our 1.0, we thought, we can leave consolidated logging just for a little bit, which is you can't. As soon as you get past 2 machines, you've got a problem, right? You need solutions. So one of the first things that you find yourself doing when you're using orchestration solutions is setting up things like consolidated logging, and that could be forwarding them to Splunk or to other hosted solutions that provide that. So we want to provide that out of the box, and we feel very concerned about security as well, right? And security is something you have to bake in right from the very beginning. It's not one of those afterthoughts. It has to be part of the team's culture itself. And then with monitoring, as I mentioned, we cover 4 areas really of metrics, through flows, through events, and logging. And we want to do things there. Probably one of the most demanded features, of course, is tracing through, not just through active systems, but active systems that are clustered together, and then those that are not even clustered together. Right, so clusters that communicate through other clusters, and then at the lower level, being able to trace through futures and through actors themselves. And so we've already built instrumentation at a very low level in our monitoring solution, and now we're building out from that, so we can provide a very comprehensive set of instrumentations. And just one more thing on the monitoring thing, with that fine granularity of information, once you've got that data, and there can be a lot of it. I think Netflix were mentioning like 1 billion transactions in some ridiculous amount of time, I don't know. But that you can have a lot of data coming out, but once you've got that data available, then you can start making some really nice, customized, highly tuned decisions on understanding, what it means for a service not to be meeting its SLA and so forth. So we're focused on that. So what we'd like to start off with is, to save me talking and showing slides, is to actually show you a demo, first of all, of a process, and a process dying, okay? And it's a very sad moment, so I hope you've got your handkerchiefs. But processes can die, of course. They can die for a variety of reasons, out of memory conditions, bugs. They occur, not in my code, of course, but in other people's code, bugs can occur. And of course, they can terminate gracefully as well. So we like to see how these systems, how orchestration solutions can actually deal with these conditions. And whatever orchestration solutions you might be looking at when rolling out and managing your distributed systems, then I hope that you can remember some of the use cases that we're going to show today, and apply them to form questions around whether they actually handle these situations. And so hopefully that will help you. And so Marcus is going to do this first set of demos. So good luck, Marcus. And as I say, you might see grown men cry. But we expect a lot of applause when things go right, just so you know. All right, so over to you, Marcus. Thank you.
Yeah, thank you, Chris. Thanks, Chris. Thanks for the talking. So let's go to the juice. So I hope the demo got on my side this time. So as Chris said, we basically will show what happens if an application gets terminated, and also what happens if an application gets normally stopped, right? So we've already set it up a ConductR cluster that's actually running here on my local machine. It's this 3-node cluster. So this 3 blue dots are basically the ConductR instances running on my local machine. And we also have certain applications already deployed, which are running, that are basically the green dots here. Right? We call them for now bundles. So that's basically our packaging algorithm, how we package applications as bundles. You also could reference them as containers. So now what we're going to do is we first want to load or deploy a bundle into our ConductR cluster. For that, we are using our command line interface, which you can install. And you can just say conduct load and then specify the bundle. It's basically just a zip file. And as you can see, it's really fast. And let's filter now for this bundle. And what happened, it was not only deployed on one instance, but it was actually getting replicated across all instances, right? So when we do a scaling, which is the next step, the scaling will be really fast because the bundle itself was already transferred over the wire into the ConductR cluster, and now the scaling will be really fast. So if you compare that, for instance, with Docker Swarm, if they scale things, they first download the Docker images from the internet, and it can take some time until things are getting scaled. So to scale the bundle, to start a bundle, you just say conduct run, and then specify again the bundle name, test bundle. And now if we go back to the visualizer, we actually see here now on node 3, or with the IP address 3, that the bundle automatically has been started, right? So the whole point of our presentation is about talking about failure cases and resiliency. So let's actually terminate this test bundle, right? I will simulate that by logging into this node and killing the process ID. Locally, we are leveraging Docker, so each ConductR instance is running in one Docker container, just to get that going locally. So let me check on what kind of machine I need to log in. That's cont1. Now I try to find the process ID. That's 8 9.6, and now let's kill it. Afterwards, I will switch to the visualizer, and then we will see what's actually happening when we terminate a process, right? When an application gets shut down abnormally. So as you can see, it was really fast, right? We are reactive. We are fully event-driven. So, but as you could see, maybe the bundle got automatically restarted, right? So if an application terminates, ConductR automatically restarts the application. So there are also certain applications, like think about certain worker scenarios, which spin up, do some work, and then directly shut down. Right? So in these kind of scenarios, what should ConductR do if an application shuts down normally, gracefully? So let's check it out. So let's have a quick look at the application, what it's actually doing. It's just a very simple Akka application with some HTTP endpoints. And here we can call a certain endpoint. And another thing we can mention is if you look at the URL, ConductR automatically contains proxying and a service locator, so that depending where the bundle is running, right, it can run on different kind of instances. It's automatically get resolved by ConductR. So you can specify certain service endpoints when you load these bundles, and ConductR automatically figures out on what kind of instance this bundle is running. Okay, another feature is, which Chris mentioned, is to have consolidated logging out of the box, right? So what I also can do is I can say conduct logs, and then again test bundle, and then we see basically the log messages from this application. And here we see that actually a certain HTTP endpoint, a shutdown endpoint exists, and that basically will gracefully shut down this application. So let's call that. And then let's switch back to the visualizer and actually see, let's have a look how ConductR behaves. So I click it, and again, it's really fast. And as you can see, there's no green circle running anymore. So that means the test bundle is not running, right? Because it was a graceful shutdown. So that were two scenarios. Thanks for clapping. So that were two scenarios basically where you can see that depending on the exit code, termination or graceful shutdown, ConductR handles like stopping a bundle differently. Okay, so that was the first demo. Now let's switch back to Chris, and he will talk more about the Akka split brain resolver.
You can clap if you want to, right? So. At some levels, it might seem quite rudimentary, but if you can imagine yourselves with having tens of or even hundreds of nodes, being able to have something look after your general well-being by preventing those calls from occurring at 2 a.m. in the morning. That can seriously help you. It does happen, as I said before. Processes leak memory, they run out of memory. The Linux out of memory killer will zap it, if it exceeds the C group setting and so forth, right? So it is our reality and you don't want that, in the middle of the night. And so it's there to watch your back. So what we want to talk about now, right, because as I say, that might seem like a fairly rudimentary one. We want to talk about a scenario now, as I said earlier, that is real. We hear about these split brain style scenarios, perhaps, but it won't happen to us. But it does happen. It does occur. We have network partitions that occur more often than not. And as I said also, it's largely an unsolved problem. But we have this thing called the Akka split brain resolver. And you can ask it to follow any one of a number of algorithms. In fact, it composes a few algorithms to determine, for example, what the majority side of the cluster is and what the minority side of the cluster is. And it does it in a very deterministic way, because of course these things can no longer communicate with each other. The prerequisite to any systems like this is that there has to be some settling in time, some bedding in time, right? That state can become reasonably consistent because it is an eventually consistent model, right, throughout your cluster. But that level of consistency can be attained in milliseconds to a second. It's really very, very fast. So from the perspective of being practical, this has been extremely effective for us. And what you'll see is that we will introduce a network partition into our cluster, forming a minority portion of it, and a decision will be made by SBR to down that node. But not only that, it will then recover, right? So, if the demo gods are on our side today, it will then recover and self-heal and rejoin that cluster when the network partition heals. So, Marcus, over to you again. Let's have a look at this one. You're not crying so far, so things are going well.
Yeah, let's have a look. I mean, the first demo was a simple one, so now it's getting interesting. Okay, so let's go back to our cluster. Again, like 3-node cluster. To actually see some things, first let's scale down the test bundle. This time not to just one instance, but to 2 instances. You can do that by just specifying a certain scale, in this case 2, and then again the name of the bundle, test bundle. So now we see how the test bundle is scaled up to 2 instances. All right, and so 2 instances are running. So now let's have a closer look. Basically, the IP address 2 is node 1, 3 is node 2, and the node with the IP address 4 is a third node. So now what we're going to do is we create a network partition between node 1 and node 2 and the third node, right? That means the third node will not see node 1 and 2 anymore, and the way around, node 1 and node 2, they will not see node 3 anymore, right? They can't communicate with each other anymore. And yeah, let's just do it, and then let's see what's happening, and then I will explain it. Okay, so let me log into the third node to actually create this or simulate this network partition.
A network partition. It is actually a real network partition. Just to make it more exciting, to get those claps even louder next time, or not.
Okay, so I hit enter, and now the network partition occurs. And now what we should see in the visualizer is that you see that, right? The third node is pulsating, is bumping. That means basically that the other 2 nodes, they don't see the third node anymore and mark it as unreachable, right? And we will give now the third node a little bit time to connect again to the first and second node. And after a certain period of time, basically 30 seconds, Akka SBR will kick in and will down this node from the ConductR cluster, right? Again, like ConductR is leveraging Akka cluster, so we are leveraging here Akka split brain resolver. So now we have like really a split brain scenario where we see in the visualizer we only see like the original ConductR cluster, but there's actually also still the third node still exists, right? And what actually ConductR does is it will restart the actor system of the third node. So if we go to the third node, we still can communicate with the third node by doing a REST call to this node. So let's do that, just to verify that it still works. And as you can see here, basically I still can communicate with the third node. It's just the case that our cluster doesn't see the third node anymore. Also, ConductR did a couple of other things after Akka split brain resolver kicked in and downed the node. As you maybe remember, we started 2 instances of the test bundle, right? And on the third node, there was actually 1 instance of the test bundle running. And if you look now at the visualizer, actually the test bundle is running on node 1 and node 2. So basically ConductR will or knows what kind of bundles are running on the node which got downed, and will automatically rescale these bundles on the existing nodes. Right? What it also does is it will restart the actor system of the node which got down, so our third node, to ensure if this node is coming back again and joins the cluster again after the network partition goes away, that we don't have an inconsistent state. Right? Because like this, the network partition can stay for minutes, for hours, and in the meantime we can scale new bundles and so forth. So let's remove the network partition. And yeah, now the third node is joining again. Now it joined, and as you also can see, we are not scaling the test bundle on the third node anymore, but at least we are replicating again the bundles, right? So that the scaling again is really fast if we want to scale it now to 3 instances back. All right, back to Chris.
Wow, unsolicited clapping. I've not experienced this before. That's awesome. So, again, just to underline what you've just seen there, I don't know about you. I've not seen this demonstrated by other vendors. You know, split brain is a topic that is often avoided. Right, so I really hope that you can take what you've just seen there and then go and ask, similar questions of the other communities, whether this situation is being handled, because it's quite real. Is Katrin? Questions can come afterwards. Is that all right? Thank you. All right. So while Ed's going to prepare for the grand finale of all demos. I mean, you've seen nothing yet, right? I just wanted to hit a few points on where we're going with this right now. And it's labeled as roadmap, but in fact, what we're going to show you now is real. When we put these slides together, it was perhaps a little bit of a roadmap style of feature. But we already have DCOS integration, so there's been a lot of discussion. Thank you, unsolicited clapping again. We already have DCOS integration right now, and we're in beta 2, and we'll be going for beta 3, and that beta 3 program will be open from next week, we hope, when we all get back to our respective countries. So this is for real, and this is what we're going to be showing you a little of in a moment, because with DCOS, as you can appreciate, it's a complete data center operating system. There are many more moving parts, and therefore many more things that can go wrong. Things that we felt we want to, of course, continue with our very strong theme of resiliency and make sure that we can stand up in the face of failures there too. So we're going to talk about that. We have a preview of automated continuous delivery in progress as well. And with continuous delivery, you can publish to repositories such as Bintray and receive webhooks automatically, and then have automated rolling upgrades of your services, or done again in a very reactive manner. There's no polling or going on here. I mean, what you've been seeing here today, with a visualizer, it's been very reactive, and we continue this theme through our other solutions, including continuous delivery. Auto scaling is not just a pipe dream. We have all of the infrastructure in place to make auto scaling happening. I mean, today you can achieve auto scaling with, for example, AWS, right? You can do that right now. You can set your target scale for your bundles to be 1,000, whatever. And if you've only got 3 nodes, it's just going to scale to 3 nodes. And when a 4th becomes available, then it'll go to 4. And if you reduce that, it'll go back down to 3. So you can do that right now. But we don't consider that to be real auto scaling. I mean, scaling of infrastructure is important as well, but often resources within the infrastructure you've got are typically underutilized. and we'll do a good job of bringing those resources down when they're not needed, so that you can scale up within your infrastructure in parallel to being able to scale up infrastructure as well, right? Because scaling up within infrastructure can, you were talking in a magnitude of seconds rather than necessarily minutes, to scale up new virtual machines itself. So being able to make those decisions based on that fine granularity of metrics coming out from monitoring is extremely important. And we also want to bring our machine learning expertise. We have a wealth of machine learning expertise within Lightbend. We want to apply that to auto-scaling as well. It's not necessarily the biggest machine learning problem on the planet to solve, but it's a good one, right? And so we definitely want to do that. And in fact, actually, just on the machine learning topic, we're also extremely keen on automated profiling, using these metrics that we can gather from our processes, and then determine, if they're about to blow their reserve memory size, their resident memory size, and integrating with continuous delivery, automatically reconfigure that process for you and learn about what that process behavior is. Because let's face it, as developers, we're not as good as we should be in terms of profiling our apps and understanding what their resource requirements are up front. We just want to just put it out there and worry about all that later, right? But we can use machine learning to help us here. Security is a massive, massive topic for us. Because we have this influence over the orchestration aspects of things, we can make things like mutual TLS authentication and encryption between services a lot easier. In fact, quite easy from a developer's perspective. We believe that we can do this without any consideration from the developer, all right, and make it an orchestration concern, and we can do it in a very secure way without writing private information to keys. So we have this figured out right now. And then indeed, as we've been alluding to, more monitoring instrumentation, the more things that we can instrument at the JVM level and up, the better decisions that we can make. So now Ed's going to show us how things look on DCOS and explain a few differences as well between the visualizer that you've seen so far in standalone mode versus it running on DCOS. So over to you, Ed.
All right, thanks, Chris. All right, so first, DCOS 1.8 control panel here. In case you guys haven't seen it before, it's pretty standard that we integrate with it properly. And so yeah, we're just another full framework registered with Mesos DCOS as one would expect, just like Cassandra or anything else you might install from Universe. So cool, there we are, great, exciting stuff, right? So as Christopher said, things get a little more interesting here. Now we take a look at our visualizer in the DCOS environment and we see more dots, right? And just to help you guys cut through this, the three larger ones, what we refer to as core nodes, Mesos would call those schedulers. So these are the ones managing the scheduling. And then on every node of the cluster, we have an agent or an executor. So this is the process that's actually going to launch your applications on the node itself. So we've got an agent running on every one. Cool, a couple of nodes, great. So we're live on a functioning cluster. Awesome. This is a real one, not on the laptop or anything. It's actually on AWS. And to the extent that one of these bundles, called ConductR, is actually the template engine that we use to run our documentation for ConductR. So I believe we should be able to get to, so great, there's a copy of us running under this other host name. So there is ELBC name for this and proxying in front of our cluster. And this is something you can load up locally if you so inclined. So cool, great, DCOS, real, happening, awesome. So we're kind of like, all right, well that's cool. We've seen a lot of failover, split brain resolver and killing a process. And that's great. So but part of this is a Reactive Summit, right? And if you know Mesos DCOS a little bit, they have that zookeeper thing in there. So they're a little more big C than whatnot, and that's fine. But we can bring a reactive element to that, right? We are reactive from the core. As Christopher explained, we're in a masterless Akka cluster. Make sure I get the right visualizer. Right, so there is no master here, and we're using CRTDs to maintain state, so it's a very reactive environment, and we can react very quickly. So we're kind of like, all right, well, that's cool. What can we do that's kind of, really extreme here? Let's break this, right? Let's really bite our thumb at the gods and see if we can get away with it. So what we're going to try here is, this is a 3-master cluster. So, hopefully we did everything right, and maybe a AZ goes down, we'll still have some masters. But maybe we weren't so lucky today. Maybe all 3 masters happened on the same rack. I can't place that, so maybe we just had a bad day, and gosh, we forgot to put them in multiple AZs or something. So what I'm going to do is kill all 3 master processes in the cluster, and see what happens. Yes, Mesos master, because we're masterless, right? So, where did I lose my shell again?
So it's very important goal for us to be able to continue operating in the face of failure. Mesos is highly resilient in its own regard, but of course, its master nodes can be sitting on a different subnet to our core cluster itself, right? And there can indeed be network partitions that can lead up to these events. So this is the scenario that we're looking at, not suggesting at all that Mesos itself is not resilient. It is, but network partitions can occur.
So we're going to kill all 3 Mesos master processes, and let's see what happens. So we're going to stop those. So at the end of the day, it's kind of boring, because nothing really happens. So I was kind of like, well, that's kind of boring, in a good way, right? Because we like boring in production, right? We don't want surprises. So let's make sure this is still working. All right, cool. So our app's still up. Yeah, I know, really. Did you really? Well, let's see what DCOS says. DCOS is, all right, try services. Take a look here. Let's see, cache. So Mesos is dead, and we survived. That's it's boring, actually, because nothing happens, but we like boring in production. So that was a case of kind of an extreme failure where we basically killed the Mesos cluster. Now, certainly someone's going to have to come and mop this mess up, but we can survive quite comfortably, as we've done in other scenarios, and continue to live on with confidence. So that's how we kill Mesos and still live to tell the tale. Thank you.
Thanks, Ed. I think the demo guards actually have been on our side today. Kiki, I think you wanted to come up and do a demo. Was that right? Because next time, okay. So things have been going really quite well for us. So if we could just get.
It's good to be lucky.
Cool. I just wanted to explain as well that ConductR is not, and the production suite is not a new thing, right? It's been around for a couple of years. Our DCOS integration is relatively new, except, but it's not like we've just created this and it hasn't gone 1.0. We're actually showing you here 2.0. So it's great that the demo gods are on our side today, but I'd be kind of upset if things weren't working for us right now, because they've been working pretty well in production for us. In terms of next steps for you guys, it is free for developer usage right now. You can go to that URL and get started with the production suite very quickly. We say actually in 10 minutes, others say 20, but we say 10 on the basis that you know Docker, right? That's the prerequisite, right? It is a prerequisite to run things locally. So once you've got Docker up and running, which is not difficult, Docker Inc. are doing a fabulous job of making that very accessible. And what I'm also excited to say that in the not too distant future, we're talking in terms of weeks, then we hope to make this available free for production use in certain scenarios. So you can clap again for that if you want. So anyway, I'm really pleased. Thanks, guys, for doing the demos. Do we have questions at all? Yes, sir. Do we have a mic or no mics? I've got the mic.
Yeah.
When is the DCOS version available for production use?
Right, thanks. So when is the DCOS version available for production use? Our intention is to release in either this month or next month. It's imminent. We are at beta 3 right now. And well, as you can see, things have been working pretty well for us. What we like to do is to soak test these things in our own production environment first, and understand, feel some pain sometimes, and so that's it's the situation now is that we are functionally complete, which is why we're in beta, and now we're just making sure we're doing our soak tests and fixing little bugs here and there, with the code that other people write, not me. I'm just joking. And so imminent. Yeah, thank you. And you can sign up. Actually, if you're interested, please contact us because we can get you signed up for a beta program right now, so you can get your hands on beta 3, which will be next week. If you want to give that go, yeah.
I have a part 2 question.
Sure.
The scenario that you showed where you killed the visual masters while the conductor still continued running the instances of the microservices of the application you had. In that state, could you scale up?
No, you cannot. Right, because that is a Mesos responsibility, right? It is taking care of, it is the resource provider and the means to start new task executions within the cluster. So it's about staying up, but also, being in this state of, well, I can't really do anything right now because things are compromised somewhat. Yeah, so we're not trying to take on the role there. We are fully and tightly integrated into that world as a Mesos framework. In standalone mode, of course, we have our own very simple resource provider, but it's certainly simple by comparison to Mesos, and that's indeed why you would look towards using DCOS. It's a lot more sophisticated in that regard. Yep.
The case that all Mesos master are getting terminated or going down, right, is very rare. I mean, we just wanted to show like an extreme case. I mean, usually you deploy like, let's say 5 Mesos master instances, and then one goes down, and then Mesos master automatically does a re-election to another Mesos master, and after the re-election occurred, of course, you can do the scaling again, right? So that's like normal, like for framework such as ConductR, that it behaves correctly. But we just wanted to show what even happens if a complete Mesos master is unavailable.
More questions? Katrin, sorry, yeah, sorry.
I was wondering, when split brain occurs, and there's something going on in cluster before the things that went down rejoin. For example, you deploy a new bundle. As those actions, those operations are being queued and replayed when the things join back, or it's something lost on the part that rejoins?
So when connected to the majority cluster, then you can continue, right? Once Akka cluster has moved between its unreachable state to its member down state for that node, then a leader again, can be determined within the cluster, and so life can continue within that cluster itself. So nothing gets queued up; you can continue operating.
No, my question is, but if, for example, I know that when we have bundle and when it's being deployed, we put this bundle replicated to all the nodes.
Yep.
So the nodes that were partitioned and then come back,
Yep.
do they get the replication, or this replication is lost?
They get the replication when they come back. Yep, and actually that we did show that, so you weren't paying attention, Katrin. Okay. I'm just joking. No, it actually did replicate. Actually, when that member came back, I saw it, right? I saw those dots come back. So we can...
Deployed a bundle while it's partitioned.
Yes. There are a limited set of functions that can be performed while in that partition state. So that partition state is represented by Akka cluster when you're in that unreachable state, and it can't determine a leader itself, right? So you can only do a limited set of operations at that point in time, and that takes about 30 seconds to resolve, depending on configuration. Yeah.
Yeah, I guess if it helps, once that's split, you basically have a cluster that's just smaller than two-thirds of what you had. So it's still a cluster. Once it's reconciled, it's still a cluster. It's just smaller.
There's a question at the back.
My question was more comparing Reactive to other solutions, especially if you're in Scala but have other things in your stack. You want to leverage conductor, you want to take the investment from two different. So how is that primarily for the Reactive ecosystem, or how is conductor today? Is it all the zillion other orchestration tools that are coming out?
Right, so the question is ConductR in the production suite, is it primarily for the reactive platform, or can it also consider non-reactive things? And there is a marketing answer to this, and there is a technical answer to this. So I'll give you the technical one. And the technical one is that, at the end of the day, we are managing processes, and we are agnostic to what those processes are, right? That's it. It's an active supervisor in a sense, for processes. That's the shortest answer I can give in that regard. In terms of the DCOS integration, we integrate at an extremely low level, the lowest level that we can, to leverage DCOS. So by way of example, with service discovery, then we offer service discovery for what ConductR itself manages, and that's very, very fast to resolve. But if we can't resolve a service name within what we manage, then we fall back to DNS-SRV, right, which is what Mesos provides out of the box. And so actually with Kubernetes and Console, they all support DNS-SRV as an API to them. So we can therefore service locate Elasticsearch, Cassandra, Kafka, and whatever else you're running on your DCOS cluster. Indeed, even other microservices that you may have and deploy and manage through Marathon, if that's how you prefer to do things, particularly if you're using Docker. We support Docker also within ConductR, but if you prefer to use other mechanisms to orchestrate your Docker containers, then you can do so. And I would suggest that JVM processes need less containerization by Docker than some others, like, for example, Ruby or Node or whatever, that needs its runtime dependencies satisfied. The JVM goes a long way to satisfy those dependencies. So always question, I would question that as well. Don't just put it in a Docker container for the sake of it, because what Mesos will give you in the context of DCOS is C groups, right? So you actually get quoted, limited to CPU memory and disk usage. Anyway, they are containerized in the true sense of actually what containers actually mean, which is a philosophical conversation that we could have, right? So hopefully that answers your question anyway. Yeah. Yes, sir.
What does ConductR provide that DCOS doesn't?
So what does ConductR provide that DCOS doesn't? In the context of Marathon, for example?
DCOS, like what does it give you on top of Mesosphere DCOS?
Okay, in terms of, so DCOS itself has built-in orchestration through Marathon, of course, and underneath, it builds upon Mesos, and Mesos supports this notion of frameworks, of which Marathon is a framework, and there are many orchestration solutions for the Mesos ecosystem, including Twitter's Aurora as well as another example. So what we have gone out with a particular focus on making sure that the reactive platform is managed as best as it possibly can be. And perhaps one of the most obvious things that we do that others haven't taken care of out of the box is managing Akka cluster style applications and services. So with clustering solutions such as Akka cluster, it has a requirement that you must start the first node in isolation of the others, right? Where it needs to establish the cluster, and then once it's established, other instances can use that IP address as a seed and join it, so you don't get a fraction of clusters. If you look at other orchestration solutions, if you say I want a scale of 5, it'll start all 5 in one go, right? And in an Akka cluster scenario, you then have to work a lot to manage. Okay, well, which one's going to be the first to start up, and that's very hard to determine. So we built that in to our orchestration tool. To provide that guarantee that the first one is always started in isolation of the other ones. So that's probably the most obvious thing. But then also the integration with our monitoring solutions is very important. So we want to provide this, again, complete batteries included, out-of-the-box experience, nothing else to consider. You've got consolidated logging, and off you go. But probably the Akka clustering is the biggest thing. And once you've got that, then you can also add split brain resolver to your own Akka cluster, that are formed, and have those managed.
I'd add the developer experience too. I mean, as a developer, I don't have to think about DCOS, right? I just kind of, okay, it's another distribution target out of SBT. If I'm using SBT, if I got logon, I have a DABS file, basically just run all install. As a developer, I don't have to think much. So I have good production points, but I can go, as a developer, I like it because I don't have, Marathon, what's that? I don't know. I just push my bits and they show up on the cluster. I'm lazy, so.
No, that actually is the correct answer. That's a fine answer, Again, no, you got it right, yes. It really is about, I did say at the beginning, we're there to hold the developer's hand all the way in through to production, right? And
we've done this. It's a pain in the butt. Yeah. We know. That's why we built this.
And, the developer doesn't have to understand DCOS at all, right? And, you as an organization don't even have to go to DCOS in day one. But, whatever you do here, whatever you get up and working in a production suite environment, you can actually migrate to DCOS with zero change, okay, to your applications and services. So we actually see it also as a stepping stone to being able to make a bigger decision as well, to move to DCOS when you're ready to move to DCOS. But it is all about the developer experience. We want to make that simple and streamlined as it possibly can be.
Good question.
Great question. Thanks, Ed. Yes, ma'am.
Got in trouble again.
Thank you.
How do you deal with data divergence? So once the network partition has been resolved, what happens to divergent data in the two clusters? Do you resolve or do you merge automatically? And what if there are conflicts in data?
Okay. Right. So how do we deal with the reconvergence of data when network partitions are healed and so forth? And I think there's two answers to that. Are we out of time, Rich? Getting close. Okay. So thank God these questions are getting harder. Right. So to answer from a conductor perspective, there's an answer there, and then is like from your perspective in terms of if you're managing data yourselves, then how do you deal with that, right? And in fact, it could even end up being the same answer. So within ConductR itself, we use these beautiful things called convergent replicated data types, and I love saying that because everyone goes, oh, it must be good, right? But they're called CRDTs, and if you've not heard much about CRDTs, I think you're going to hear a lot more about CRDTs in the industry, and there are these data structures that have this very interesting property in that they must always know how to merge. You specify a merge function so they can always resolve themselves, okay? And databases such as Cassandra also use CRDTs, and so do RIAC, right? SQL DBs don't do well, they don't fare well in these clustered style scenarios, okay? But your DynamoDB style derivatives, like Cassandra and RIAC, this is how they deal with them, largely through CRDTs. And as I say, we use them ourselves. CRDTs, from a reactive platform perspective, are part of OSS, our open source Akka distribution, and it's called Akka Distributed Data. Right, so if you want to look more into that, then go and check out Akka Distributed Data. I don't know if Patrick's here. Patrick's the author of, or the prime author of it, but they're my favorite part of Akka, to be honest.
Very powerful.
Without those, this actually would have been very difficult to write. And it's how we've been able to achieve a master style scenario. Whereas other solutions out there are master slave. Yeah.
Another great question.
Thank you. Another great question. We should have prizes.
Wow.
Yeah. Any more questions? No? We're good. We can continue to talk after this. Thank you very, very much. And I just wanted to say, actually, before we leave the stage, I wanted to thank my team as well, for including Felix Sataputra over there in the audience, who doesn't like public speaking. You should be up here. That over the last 4 months, it's been a really intense effort getting DCOS integration done. So thank you very much for all of the help there. But thank you very much for coming today. I hope you have a great remainder of the conference, which is not much, but thanks.